is the difference between the simple linear regression of just one variable with multiple variable. So when it comes to multiple variable, you might come to a very similar conclusion, just as if you are using the simple linear regressions with just one variable. It's the correlation. So let me just see, write that down. So when it comes to correlation, simple linear regression with just one variable, we got correlation of x and correlation of y. And as I said before, this correlation will equal to the square root of r squared. So once you got the r squared, you just square root that, you got the correlation. And remember, this number is always positive. So is this number always positive? Not necessarily so. It can be positive and it can be negative. So the positive and negative sign of it is dependent on the slope coefficient. So slope, let me just got slope. So you check the slope. If the slope is positive, the correlation of the x and y will be positive because just the one variable here. And if the slope coefficient is negative, this correlation is negative because because you are using the y equals to ax plus b. So all the correlation are dependent on this a, the slope coefficient. So if the slope coefficient is negative, it's negative correlation. Okay, so very simple. And if you come to the multiple regression, you will also come to this similar conclusion, but a little bit different because we do have the correlation here. But that correlation is no longer x and y, but the expect the predicted value of y and the actual value of y. So like the whole function give you a prediction, right? Why you do the regression? Because you want to do the regression, you want to do the prediction, you want to know the correlation and all this connection between those variables, and you combine those variables together, you got the output, right? The output is the y, the prediction of y, with the actual y, and they do have the correlation. And how to calculate that? We can calculate that by square root r squared. And you might ask, if I'm going to worry about the positive or negative sign before the correlation, the answer is no, you don't need to worry about that because there is no longer x and y, but rather just y and y. So the prediction of y and the actual value of the y will be of the same sign. Whether it's positive or negative will be the same sign, whatever you do. So it's a little bit different from the with one variable. A multiple variable, we are sort of making the comparison by taking all this function as a whole. We don't need to worry about the specific coefficient. Okay, we just take the function as a whole and compare it with themselves. Right? So that's how we do it.